carry on. Progressive wave, phase and phase different. Right? Basically, we are trying to have the particle in as a wave pass through. Each particle, like this part will be here, this part will be here, and then another particle will be down there. So you want to, in phase, we are interested to identify the particle. Where is it in, where is its position in reference to a cycle? One cycle, so we identify as an angle. One cycle is 360 degrees. So if we start with the rest position and then it's going up. So at rest position, we consider as 0. We go to the maximum amplitude, 90 degrees. Then it comes down again, 180 degrees, where it's moving down. Sorry. So you can think of the motion as going up and down, and where it's at the minimum position there, going upwards there is 270 degrees. Or you can think of it as it's moving up, it's going clockwise. 90 degrees in a circle, 180 degrees, 270, 360 degrees. Right? Want to identify the particle in its motion. 90 degrees will be at the top there. 180 degrees will be at the rest position but going downwards. Okay, so this is just to show you the circular motion and the vibration. They are related. In phase different, we want to know the position of the particle with respect to each other. Phase and phase different. Phase describe the relative position of the crust or trough of two waves of the same frequency. Sometimes we are interested which wave comes first in time. We can compare the crust or corresponding point. In this case, P leads Q by a phase of 5. Right? So we can identify the corresponding position, this straight one with P and this same point Q. So in terms of wave P comes first, so we say leads. Right? It leads. Or we can use the crust to identify the crust and the corresponding crust. Right? Wave P leads wave Q. And the different is called the phase. Right? Or phase different. So phase different, time and graph and distance, is basically looking at sine curve in terms of angle, or in terms of time, or in terms of distance. So if we start with 0, a quarter T, half T, then it comes down to 3/4 T, and then come back to T. In terms of angle, it will be 90 degrees, 180 degrees, and in this time, this is the phase. Right? Memorize this formula, is proportional. Right? Pi over 2 pi. You actually don't need to know radian. Your AS, you need to know degree only. 360 degrees equals to 2 pi radian. A2, you require to know about radian. Right? In terms of lambda, it's a quarter lambda. This is 0 lambda. And then in terms of time or phase, this becomes x if it's distant. Right? Same, these two formula, you need to know how to use and memorize it. In phase, yeah, oscillating in phase. Amplitude doesn't matter. As long in phase, when the crust and trough of the two waves are aligned. Right? In this case, the crust and crust align, crust and trough align, they are say in phase. Antiphase, or another way of saying is 180 degrees out of phase. When the crust align with the trough, crust, trough is 180 degrees out of phase. I tend to use radian, 2 pi radian is 360 degrees. Pi radian is 180 degrees. What's the phase difference between the two waves? Right? In this case, we look at this point there. V1 comes first. And then the phase here 45. V1 leads V2 by 45 degrees. Anything?
Yeah, okay.
Okay, Okay, phase, period, and displacement. This displacement time graph. Right? We can think of this is 0, if half the period, this is a full period. Or in terms of distance, we can think of it as this is 0, is half the wavelength, is a full wavelength. Or in terms of phase or angle, we can think of it as 0, maximum 90, 0 again, 180 degrees, and then this is 270, come back down again is 360 degrees, one full cycle. Right? They are all related cycle. We can either think of it as displacement time graph, or displacement distance graph, or displacement angle graph. Okay, we are going to describe the motion of the particle, describe motion of particle as the wave pass through. So particle A is what? Displays what?
Particle A displays.
Upwards, so it's up, it's up there. So it displays
Oh
upwards.
yeah, yeah, upwards, yeah.
And what will you describe the motion of the particle?
What do you mean motion?
Stationary. Right? You can think of your displacement angle graph, same as displacement time
Oh
graph.
yeah.
Right? So at the maximum point, the velocity is 0, so it's stationary. But the next stage is it's moving downwards. How about particle B?
Displays
Displays
downwards.
downwards, moving
Actually,
upwards, so,
moving upwards.
right? You just let the wave be displaced by a short distance away. It is here, now it's going up there. How about particle C? Displays,
Um, displays downwards, so
okay, good. Then moving,
downwards.
good. It means you are okay with this. Okay, this is just to show you what is happening. Just let the wave move slightly, then you can see whether it displays outward, how is it moving. Okay, so particle B is displaced downwards, but moving upwards. Particle C is displaced downwards, but moving downwards. Intensity. Intensity is the rate of energy per unit time. We call it P lah. Energy per unit time is P. Falling normally in terms must be that perpendicular per unit time on the surface. Right? So it's power emitted by the source divided by the area. By the area, by this area, right? That you want to find the intensity at this point. Right? Power is W, measured in watt. Area is meter square. So the unit is watt per meter square. Right? It's a vector quantity because it has a direction. Right? For a point source of energy, it can be a light source, where it sends out energy in all directions. Right? We can look into a circle of radius R. Right? So the energy is spread out in all directions. So it's P divided by 4 pi r squared. Right? It's for your info, but it's good to know it exists because it helps us to understand that as you go further and further, the sound becomes softer and softer. It's formula, right? No need to know.
Oh, okay.
If you require, examiner will give you. Right? That means as you go further and further, the intensity or the loudness becomes smaller and smaller. Right? Intensity of wave decreases with distance. There are two reasons. The wave spread out, or the wave is absorbed or scattered as light pass through the Earth's atmosphere. Right? When we study the oscillating spring, we say that the energy equals to half k1 y0 squared. Right? Y0 is the amplitude. K is the spring constant. So intensity of wave is the same. Right? When we use power energy are related to each other. So intensity is proportional to amplitude square. Right? Or we can write as I equals to Ka squared. Right? K is not the spring constant, it's just a constant, that's all. Right? You won't bother about that. The examiner can ask you to do all that by giving you all the info. Question: what's the unit for K? What's the unit for K? Right? They can ask you. Get it from the formula, though. I over A squared. K, right? I is W meter square per meter square divided by A, amplitude meter square. Right? So it's W meter to the power of minus 4. Right? In terms of base unit, you should be able to do that. Same thing. Right? If you don't know power, can derive it. Power is energy or work done divided by time. Right? You get kilogram meter square S minus 3. So same thing there. Right? Energy, that's your power. Power, what is given by that? And then n minus 4. To simplify it, so that's the base unit. Don't memorize, know how to get it. Important. Examiner can ask you in a multiple choice question, anything related to what you study. Right? So all this formula you need to remember and know how to use. Okay, let's try some of the question. You can try the rest yourself. How about this one? What's the phase difference between 2 points that are 2 cm apart in a wave of wavelength 8 cm? What's the answer?
How should I answer this?
Use the formula. That formula.
Oh, okay.
Right? X is 2 cm. X is 2 cm. Wavelength is 8 cm. And then one wavelength is 360 degrees. Then there's your phase that you want. Cross multiply. You get your answer. 90 degrees.
Oh, okay.
Okay. Okay, let's just review some of the things there. What does the symbol represent? T, what does it represent?
E is period.
Okay, good. F,
Frequency.
some people will use no lah. It's just like V lah. Cursive V lah. How about V?
Velocity.
Velocity of wave or speed of wave. K,
Constant.
Just a constant. Right? Now the unit, know how to derive the unit. I,
I, is it, wait,
intensity.
oh yeah,
A,
actually, intensity, okay.
what is A that we use?
Amplitude,
Good. Lambda.
wavelength.
Okay. Let's try some more question before we go to CRO. Okay, this is the displacement time graph of a particle or medium as a wave or wavelength to 2 cm is given. Calculate the amplitude. Displacement time graph. What's the amplitude?
Amplitude should be 1,
One there lah. Period.
uh,
Period.
oh yeah, period is
Same point to the same point there. About
0
0.25 lah. 0.25 second.
0.2,
Frequency.
four,
Hmm.
4 hertz,
1 over the period of 4 hertz. What's the speed of the wave?
wait,
Basically getting you to play with the formula that
also
we
4
read.
hertz.
Right? We are going to
It's
use
oh yeah, because 2, okay,
F
okay.
lambda. Right? Frequency is 4. Yes, you can calculate that. And then wavelength. Wavelength is 2 cm. Right? 8 cm per second. What's the phase difference between P and Q? F, I give you the answer. I can go back and think about it. I don't know, you can ask me.
Okay.
Half the amplitude, but twice the frequency. What's the phase difference between P and Q? There's your P. There's your Q. Right? 3 as a sine graph. And then the horizontal axis, 3 as angle. Can, right? This is 0. This is 90. This is 180. 180 minus 90. Right? 3 as angle. Instead of displacement time graph, 3 as angle. As you read, 180 minus 90 is 90.
Oh yeah, 90, okay.
P and R. What's the phase difference between P and R?
Okay. 270 minus 90. 180.
Good. Which point is at maximum velocity? Make sure you try the rest yourself. If not, I will
Okay.
ask you next week. Yep. Which point is at maximum velocity?
Maximum velocity should
Just treat as
be
displacement time graph. Which point?
is it E?
Okay. Maximum velocity. Maximum velocity.
Oh, wait, wait.
Gradient, gradient, gradient. Gradient, gradient.
D ah.
Right? You must know in terms of vertical motion, A is at the top there. Right? So it can be B, can be D. Right? We are interested in magnitude only, not direction. Right? By a particular with a maximum velocity D and H. So zero velocity.
Zero was it should be E ah.
A or E, or it can be C and G. Kinetic energy is maximum.
Um, A or E.
Right?
Ish.
Maximum velocity, B or D. So it's B or D. It can be
Oh yeah, teacher,
B or
because
D.
maximum
Or it can be
velocity
F. Highest velocity, where you get
highest
kinetic
velocity.
energy, you got maximum speed,
Oh,
maximum
okay, okay.
acceleration.
Acceleration E or A. E.
A or E,
Mm.
right? We are looking at magnitude only, rather than direction also. It can be C or G. But if you are particular, the acceleration is down there, negative. And then where is negative, acceleration is positive. Right? There are different directions you study in simple harmonic motion. Okay, let me see if there's anything else that I want to ask you. I think the rest you can try yourself. Let's go to CRO, 7.6, page 180. I won't review with you how it works. This is the one that you use in your lab. We tend to pamper the student, right? This is more expensive. When I study in New Zealand, I don't not allowed to use this one, only second year. First year, something cheaper than that. Right? This is the prop. It's a cable with connector. That's the ground. That is a thing that you clip onto. Right? So it's two wire together. Right? Don't worry about the advantages. It's for your info. Electron beam behave as a pointer of negligible inertia. Can measure DC and AC voltages and frequency. Infinite resistance to DC. Uses, this is you must know, as DC or AC voltmeter. Display waveform and measurement of frequency. Measurement of time interval. Measurement of phase. Okay, so that is the control. The Y gain, brightness, I won't go into that. Right? There's a time base. It doesn't have 3, it doesn't have 4. Right? It got 1, 2, 5, and then 10, 20, 50 microsecond. Okay. Right? It got Y gain. Give the vertical scale. Right? Time base, give the horizontal scale. Each division is 20 millisecond. Vertical scale is 1 division. 1 division is 0.5 meter. So in this case, peak to peak voltage. What is the peak to peak voltage? Can you calculate out?
Uh,
1, 2, 3, 4, 5, 6. Peak to peak. Maximum to maximum.
yeah, 6.
Minimum. Right? So 6, 6 times vertical one is 0.5. So you get 3.0 volt.
Okay, which page are you at?
Say again,
Which page are you at?
I'm at very far towards the end there. Can you find or not? Page 100,
Oh, my
page
iPad hanging.
nearly 180 there. Page 180 there. Are you with me now?
Oh, wait, oh, my iPad is hanging.
Page 180.
Okay, I'm at page 180.
How is the frequency? What's the frequency of the wave?
We'll see. Wait, teacher, I don't think I'm seeing the same thing as you.
This example, not worksheet yet. Before the worksheet,
Oh,
I
example.
call it 7.5. Supposed to be 7.6, but I made mistake.
Oh, yeah.
7.5. End of the note before the worksheet.
Oh, yeah. Okay, I found it. Okay, you can see it.
What is the frequency? Find the period first,
4 times 20.
4 times 20 is in millisecond. How is the frequency?
1 over 80.
Right? You have to convert it. So 1 over 80, 80 millisecond. Right? You have to times 1,000. No? 80 times 10 to the power minus 3. 10 to the power minus 3, you take to the top there, becomes 1,000. No? Can 12.5 hertz.
Yes. Oh, teacher, is it because it's millisecond?
Yeah, millisecond.
Oh, okay.
So millisecond, you convert it is 10 to the power minus 3. 10 to the power minus 3 in the denominator. You have to take it to the top there, becomes 1,000. No?
Yeah.
Okay, let's go to the worksheet. Try this one. Time base on a cathode ray oscilloscope is set at 6 meter per second. 6 meter per cm, sorry. A trace consists of 2 pulses. Is recorded as shown in the diagram. What is the time interval between the 2 pulses? So this is you are using the CRO to measure time. What is the time interval between the 2 pulses? Can
B.
right? This is November 203. They do repeat their question. Right? Time base is 6 cm, 6 millisecond per cm. Solution. Time interval. Right? Use this one as a time interval, not the vertical. Vertical is a distraction. Vertical is the amplitude. Right? So it's 4.5 times 6. And remember, cm and cm will cancel off. So it's 27 millisecond. Donkey.
Oh,
Okay. Any comment?
don't have.
Okay. What's the answer for this one? The sound wave is displayed on the screen of the cathode ray oscilloscope. The time base of CRO is set at 2.5 millisecond per cm. What's the frequency of the sound wave? Find the period first. Oh.
Yeah.
Yep. What's the answer?
4 times 2.5.
What's the answer?
I mean, no, the period is 4 times 2.5.
What's the frequency?
1/10.
Huh? What's the answer?
B. Answer is B.
Donkey, ah? Is it?
No, boy.
Okay, boy, correct. Oh. Millisecond, you take the inverse of it, it times 1,000. 100 hertz. B. Okay, good. Let's try this one. Diagram shows a square wave traced on the screen of cathode ray oscilloscope. The graph is a grid of 1 cm square covers the screen. This 1 cm. The time base is set at 10 millisecond per cm. What's the approximate frequency of the square wave? Yep,
Okay.
can. Try to do the question even before I teach you, since your teacher has already taught you, so you should be able to answer it. There's one period, but it's very hard to read. You can read, read there. If you cannot, right? Think this part is where it's coming down. Assume that it's coming down, and then to the next part there, coming down again. Right? Count 1, 2, 3, 4, 5, 6, 7. 7 period of. Right? 7 period equals to 5 cm. Right? The 0, 1, 2, 3, 4, 5, 5 cm. And the time base. And the period is 140 hertz. Can be. If you use a period like that, also can estimate. Either way, using more is not accurate. Okay,
Uh, so where you get 5 cm from?
I'm taking this one as coming down. This graph is coming down. So I take it to something coming down, approximate. There's a slight error there. Right? So this is 1 cm, 2 cm, 3 cm, 4 cm, 5 cm.
Oh, okay.
Anything still not clear?
Yeah, clear.
Anything else that I want to do? One more thing here. Prime firing of a gun and its echo from a cliff. Speed of sound is 330. Time base is given. Vertical amplification or vertical gain is 2 watt per cm. This is the path that you see. Gun fired. Echo. Right? You want to look at that's where the gun is fired. That's the cliff. The echo is received back. Right? X distance between gun and cliff. Right? So what's the time? What's the distance x?
Uh,
How to calculate the distance x? Can
2.2 times 2.
if you are required to find the amplitude, then it's about 2.2 times gain is 2 volt per cm. And time taken is 4 division. Take one side, this one. 1, 2, 3, 4, approximately lah. Slightly less than 4 lah. Right? Times your time base, 100 meter per second. That's 400 meter per second. So distance equals speed times time. Right? Distance is 2x, going to and fro, the echo to here it back. And so it's 2x. Speed is 330, and time, right? You have to change it to second. And calculate out your x, 66 meter. Can.
Yeah, can.
How about this one? Source of radio wave. Right? Anything will cut off. So I see you next week if we haven't completed it yet.
Uh,
Incident pulse, reflected pulse, smaller as energy is lost in transmission. Right? 0.2 is in microsecond. Right? From 0, 1, 2, 3, 4. So 0.8 microsecond. So distance is speed times time. Right? It's 2 to and fro. Remember, that's why it's 2D. Distance is D. And speed of light. Radio wave is travel at speed of light. You should know that. And then the time